Hello, good morning everyone. I'm Dr. John from FKAE. Today I will share with you a chapter 2, a topic on chapter 2 that is a second order ordinary differential equation. In the first chapter, we learned about the first order ODE. Now in this chapter, we study the second order ODE. This is the concept mapping of the second order ODE. Second order ODE divided into homogeneous type and the non-homogeneous type. Homogeneous type, is equivalent to 0 and non-homogeneous is equivalent to some value of fx. In homogeneous, we have the case 1, case 2, and case 3. Case 1 is m1 not equal to m2 and is real. And the case 2 is m1 equal to m2 and is real. And m3 is a complex number. Whereas in non-homogeneous, in which the linear equation is not equal to 0, we have to use the method of undetermined coefficient to solve it. And this fs can be consist of few types. Maybe it is an exponent, it's polynomial, or it can be trigonometry, or a combination of this exponent and the polynomial and the trigonometry. First of all, we need to know what is the terminology of second order, non-homogeneous, homogeneous, and constant coefficient. Let's say a second order differential equation in the form of this one. Okay, now let's look at this one. Second order. If you look at this equation, linear equation, why do you say that this equation is second order? Okay, if you look at this one, y power of 2. This is the power of 2. 2 is referred to the second order. This one, y power of 1, or we call it y prime. Y prime is referred to the first order. Y double prime will refer to the second order. And this equation is called linear. It's a linear form, so we call linear differential equation. This one, A, B, and C is other constant. So this differential equation is with a constant coefficient. If the equation equal to fx and this fx is equal to 0, then we obtain a homogeneous linear differential equation. So homogeneous is fx equal to 0. And then what is non-homogeneous? Let's say this linear differential equation is not equal to 0. Okay, there's some value. This means that. So this is non-homogeneous differential equation. And if the ABC is a constant, so we say that non-homogeneous differential equation with constant coefficient. Okay, constant coefficient. Now let's look at the example 2.1. Determine whether the following second order differential equation is linear or not linear with the constant coefficient or with variable coefficients, homogeneous or non-homogeneous. A, y double prime, equal to negative 4y. Okay, before we solve this question, we need to write it in the form of linear. Okay, how to write in the form of linear? Okay, ay double prime plus by prime plus cy equal to fx. So this means that we need to convert this form, this equation, into this form. Okay, so in this case, we have y double prime. So y double prime, this is y. If you compare with this one, this should be at the left-hand side because negative 4y. Y is at the left-hand side. So we move the negative 4y to the left hand side. So you have y double prime plus 4y equal to 0. And then we check whether this equation is linear, homogeneous, or constant coefficient. Okay, this equation is linear. Yes, correct. Is it homogeneous? Is it equal to 0? Yes, it's equal to 0, so it's homogeneous. Is it a constant coefficient? Yes, because it's 1 and 4. This is a constant coefficient. Okay, now we look at the second equation. Y double prime minus 4y prime plus x equal to 0. If you compare whether it's in this form or not. Yes, it's in this form. No, we can, because this is y double prime, y prime plus y. Here y double prime, y prime, this is no y. So we move this part to the right hand side. Okay, so that one will be equal to y double prime minus 4y prime equal to minus x. So equal like this. So is this linear? Yes, it's a linear form. Okay, when it's linear, you take homogeneous, you check whether it's equal to 0. Okay, it's not equal to 0, so it's not homogeneous. Is it a constant coefficient? Yes, it's a constant coefficient because it's y and it's 1 and negative 4. Okay, we go to another question. Question C. Y double prime power of 2 minus 4y prime plus x equal to 0. Again, you check with this linear form. Okay, since this one is not y, okay, if you compare this one, you must have y here. This one no y, we move to the right hand side. So the equation become y double prime square minus 4y equal to negative x. Okay, become like this. Okay, then check again. Is it linear? Not linear because it's power of 2. Okay, we cross it. And homogeneous or not? It's not homogeneous because it's equal to negative x, which is not equal to 0. And then it's a constant coefficient? Yes, because it's 1 and negative 4. Okay, we go to the next question. 3y double prime equal to negative 4x. Okay, we check. But is this correct form? If yes, we can check whether it's linear or not. Okay, 3y double prime. So it's a linear. Okay, not equal to 0, so it's not homogeneous. And the coefficient is 3, so it's a constant coefficient. Now let's look at the equation E. Y double prime minus 4y prime plus xy equal to 0. So you check this one. Is this linear? Yes, it's a linear. You take. Is it equal to 0? Yes, it's equal to 0, so homogeneous. Is it a constant coefficient? No, it's not a constant coefficient because you have the x and y, two constant. After you know what is second order, what is homogeneous, what is non-homogeneous, and what is constant coefficient, we shall move to the example. First of all, I would like to share with you the homogeneous linear differential equation with constant coefficient. Normally, in solving the linear differential equation, it involves the quadratic equation. In order to ease your life, you can use the calculator to help us to solve the quadratic equation. Okay, if you have the calculator of FX570MS, you can use this procedure And if you have the calculator of fx 570 es, you can use this procedure. Okay, for the fx 570 ms, first of all, you need to set the mode of the calculator to the mode equation. Okay, please take out your calculator for if you have the fx 570 ms, you have to set the mode of the calculator to mode equation. Okay, then press 1. Okay, mode, then press 1 to get the mode equation. Then step 2, define the degree. Okay, then you press 2. Then step 3, define the a, b, c in the equation. For example, you have the ax squared plus bx plus c equals 0. So what is the a value? What is the b value? And what is the c value? Then insert the value. Then step 4, press the equivalent symbol to obtain the first root and press the equivalent again to obtain the second root. You still remember you have the m1 and m2. So this is, we refer to the root 1 and root 2. So if your calculator screen show the r and then you have this arrow that equal to r arrow I on the right top, then press the shift equivalent to obtain the value of imaginary part. Means that is a complex number. Otherwise, if you don't have this number or this symbol, this means that it's a real number only. We don't have the imaginary part. Okay, let's say if you have the calculator of the fx 570 es, you have to follow this step. Set the mode of a calculator again to the mode equation. Then you press mode. Then you have to for 5 times. So you get the mode equation EQN. Then define the degree. Okay, you press the 3. Then you define what is the A, what is the B, what is the C. And then after that, after you define the ABC, and then you press the equivalent for the first root, and then press second time to get the second root. And also the same, if you have this symbol, this means that you have the imaginary part. You press the shift and equal to get the imaginary part. From the calculator, you may get the root 1 and root 2, or somehow you may get the imaginary part. So this is how we classify the case. So case 1 is the 2 real and different roots. Means what? Root m1 not equal to m2. So 2 real and different roots. So m1 not equal to m2. So the general solution, so you need to bear in mind what is the general solution for the case 1. Case 1 is yx equal to a exponent m1x plus b exponent m2x. Okay? And case 2. Case 2 refer to the 2 real and equal roots. Means m1 equal to m2. Then the general solution is yx equal to a plus bx exponent power of mx. Then case 3 is the 2 complex conjugate roots, alpha plus minus beta I. So this is a complex number. So the general solution is yx equal to exponent alpha x a cos beta x plus b sine beta x. Okay, so this is the 3 cases that you obtain from the calculator. Okay, you press equal symbol to get the first root and press the second time to get the second root. So you get the root 1 and root 2, whether it's not the same or equal to or same or a complex number. Okay, then you can get the general solution. So based on the root. All right. Now we Let's look at the example 2.2. Find the general solution for y double prime equal to negative 4y. Okay, this is the question. So y double prime minus 4y. And y double prime equal to minus 4y. So you need to write in the form of linear. So you move the negative 4y to the left hand side. So y double prime plus 4y equal to 0. Okay, then we change it to m squared plus 4 equal to 0. Then we using the calculator to factorize it. Okay, using the calculator to factorize it. From the calculator, you get m equal to 0 and m equal to negative 4. If negative 4, this means that is a 2i times with 2i. Okay, so this will equivalent to 4i squared. 4i squared, I squared equal to negative 1. So you get negative 4. Or we have 2i, negative 2i times with negative 2i, or equivalent to 4i squared. So 4i squared, 4, negative 1, you have negative 4. Okay, if you want to factorize it, this means it's like this. Okay, so m equal to 2i times with 2i, or negative 2i times with negative 2i. So now you'll know that I is equal to plus minus 2i. So this is case number 3. If you refer to the case in which have the complex conjugate roots, alpha plus beta I. So the general solution, case 3 equal to y x exponent alpha x a cos beta x plus b sine beta x. Okay, alpha, here the m is plus minus, here m is referred to m equal to plus minus 2i. So the case 3, you have to substitute the value, the alpha and beta. Just now you have the m equal to plus minus 2i. Okay, so this is a complex conjugate number where the imaginary is 0. So we can substitute the value of alpha plus beta I, the value of alpha and beta into this equation. Okay, so exponent 0 x a cos beta is 2. Okay, 2x plus b sine 2x. So exponent 0 we get 1, so we'll get a cos 2x plus b sine 2x. Okay. Now we refer to the second question. B y double prime equal to 4y. Similarly, we move the 4y to the left. So you change to the polynomial m squared minus 4 equal to 0. When we factorize it, what do we get? So m is equal to 2 square root of 4 is equal to 2 or negative 2. So this one is real, or which case? It's a real and different roots. So case 1. 2 real and different roots. So we have, okay, for y the m equal to 2 or negative 2. So case 1 is 2 real and different case. Then we go back to this one. Yx equal to a exponent m1x plus b exponent m2x. So case 1 is y equal to a exponent m1x plus b exponent m2x. The third question is lambda square y double prime minus 2 lambda y prime plus y equals 0, where lambda is a constant. Lambda square y double prime minus 2 lambda y prime plus y equals 0. So when you convert to m, you have m square minus 2 lambda m plus 1 equals 0. So this one you can factorize it. The lambda is actually a constant. So lambda and lambda, lambda m and lambda m, 1 and 1, so you have 1 and 1. Negative, negative, positive, so positive 1. So you can, from here, you can know that the m is equal to 1 over lambda. And this one, also m equal to 1 over lambda. So this is which case? Yes, this is the case number 2. 2 real and equal root. The general solution is y equal to a plus vx exponent mx. So m is the same. So we only write one value would be enough. Okay, that's it for the determine what is the case of the homogeneous differential equation. Now look at the equation example 2.3. Solve the initial value problem y double prime minus 2y prime plus 10y equals 0. And the initial condition is y0 equal to 2 and y prime 0 equal to 5. First of all, we need to know the constant. So we change to m squared minus 2m plus 10 equal to 0. So this is the constant A, B, and C. So from the calculator, you can press the calculator, and from the calculator, you can obtain the m value. M equal to 1 plus minus 3i. Okay, that's easy. Okay, if you want to know how to operate or how to factorize, okay, you can use the formula m equal to plus negative b plus minus b squared minus 4ac square root divided by 2a. Because this one we cannot factorize it, so we need to use this formula to get the m, the root value. So you get the m equal to 1 plus minus 3i from the calculator. So this is so direct from the calculator. So from this m value, we know that what is the general solution. You can refer to the case. You can always refer to this table. Which case? Just now we have the complex number, so we can have this equation. So the general solution is y equal to exponent x, a cos 3x plus b sine 3x. So this is the general solution for the complex number. So don't forget you have the initial condition. The initial condition is y0 equal to 2 and y prime 0 equal to 5. So y0 equal to 2, this means that when x equal to 0, y equal to 2. And y prime 0 is when x equal to 0, y prime equal to 5. So the y, okay, the y from here, the y, this is your y, okay, this is your y. So I rewrite again, y equal to exponent x, a cos 3x plus b sine 3x. So when x equal to 0, when x equal to 0, y equal to 2. So you can substitute the value. 2 equal to exponent 0, a cos x also 0, so 0 plus b sine 0. So b sine 0 is 0, cos 0 is 1. So now you have, this one is 1. So a equal to 2. Now, you need to differentiate. Okay, you differentiate. So dy over dx. Okay, you differentiate the y here. Okay. I assume the exponent xa is u. Okay, v is cos x. So u equal to exponent xa, du dx is a exponent x. Okay, then v equal to cos 3x. dv dx equal to negative 3 sine 3x. Okay, you differentiate the cos 3x, you get negative 3 sine 3x. And then you need to follow the formula u v prime plus bu prime. But first of all, you need to know, okay, why I need to use this formula. Because you have the 2x in this equation. So you have the first x and the second x. So you cannot differentiate directly. So you need to use the u and v, the product rules. So u is exponent xa, b prime is referred to this one. So you have negative 3 sine 3x plus with cos 3x is b, u prime is a exponent x. Okay. So this is for the first part only. For the first part only. Now you need to do the second part. Second part, you have the exponent x, v, and for the u, and then you assume a v is sine 3x. So assume u equal to b exponent x and v equal to sine 3x. Okay, that is for the second part. Okay, now u prime equal to b exponent x and then v prime. You differentiate this one, you get 3 cos 3x. So again, you follow the rules, u v prime plus v u prime. U is b exponent x, v prime is 3 cos 3x, plus with v is sine 3x, u prime is b exponent x. Okay, so this is for the second part. Now your dy over dx, you have to sum up these two. So you have negative 3 a e exponent x sine 3x plus a exponent x cos 3x plus b exponent x 3b exponent x cos 3x plus b exponent x sine 3x. Okay. Now the initial condition, y prime 0 equal to 5. This means that when x equals 0, y prime equal to 5. So 5 equal to negative 3a exponent 0 sine 0 plus a exponent 0 cos 0 plus 3b exponent 0 cos 0 plus b exponent 0 sine 0. So now this one equal to 1, this one equal to 0, this one equal to 1, this one is 1. So this one is 1, this one is 1, this one is 0. So this one can cancel out, this one cannot, 0, this one also 0. So just left a plus 3b. Then what is the a value? From just now, a is equal to 2. You substitute the value 2 plus 3b equal to 5. So b equal to 5 minus 2 is 3. 3 divided by 3, so b is 1. So therefore, your final equation is this one. You copy back the equation. Then you substitute the value of a and b, in which the a is 2 and b is 1. Okay, so you substitute the value a and b. Okay, that's all. Hope you can understand and you enjoy my movie. If you like my video, please like my YouTube video. Thank you very much and thank you for watching.